And it's time for another Incus release. We just released Incus 6.15 for July 2025. I'm Stefan Graeber, I'm one of the maintainers of Incus, and we're gonna go look at what's new in this release. So, this has a pretty good spread of new features as far as those releases go. Sometimes we've got some that pretty focused on VMs or network or the like. This one has a bit of everything, which is pretty good to see. We've also made some very good progress on other projects like Incus OS, I'm going to touch on briefly. Now, let's look at the new features of Incus 6.15 itself. First, we start with a feature for container users, specifically for application containers users, and that's the ability to interact with private registries. In the Docker world, and that's what we also added support for here, it's usually done through a credentials helper, which is effectively a command that can be called to then return the needed credential to access a specific URL. We've added support for that in our CLI, and now we can use that to actually access private registries and start containers from that. Next, we've got a new addition to our logging subsystem. So a couple of releases ago, I think now, we reworked how logging is done so that you can have many different targets getting different type of events. And we've supported both syslog and Grafana low-key to this point. Now we're adding another option, which is a webhook logging backend, where Incus will effectively just do a webhook call every time an event matches the criteria. So that can just, you can filter it for just lifecycle events, logging, operations, or network ACLs, and can also filter things like the log priority and like the same way you can do it with the syslog or the low-key backend. But in this case, it sends a webhook call. So it just does like an HTTP or HTTPS call to a remote server. Next, we've got some more changes to how we do memory hotplug. So memory hotplug was added a little while back, and we had some amount of bumpiness around it because of how it's tied to the physical machine as well. A lot of the test systems we have are all capable of running VMs with upwards of 1 terabyte of RAM, no problem, even if the system it's running on itself only has 16 gigs or 32 gigs of RAM. The desktop I'm on right now can do VMs with 1 terabyte of virtual memory, despite only having 64 gigs of RAM itself. But that's not the case everywhere. We've noticed, especially on older Intel platforms, that they might have some pretty low limits on the total amount of memory, things like 32 gigs of virtual memory or 16 gigs of virtual memory, sometimes even matching the exact physical amount of memory the machine has. And as part of the logic, we also need to consider that the hypervisor itself, so QEMU in our case, as well as the Linux kernel, have some amount of overhead. So you can't just look at exactly what the hardware supports and then put that as the upward limit for hot plugging, because it's gonna fail. So we did a bunch of back and forth on how to handle that. Initially, what we did was just cap the maximum to match what the physical system has. That generally worked, and it's still used as a default on standalone systems. But when you're looking at a cluster, that doesn't really work because not all machines have the same amount. So then you would live migrate a VM and it would fail. So instead what we ended up doing was adding, and I think it was like in a previous Incus release, adding details on the memory layout, effectively, the physical memory, number of physical memory bits, number of virtual memory bits, and then from that, calculate what the maximum looks like at the hardware level, and then cut that in half effectively to give some amount of headroom for QEMU, the Linux kernel, and like. That also mostly worked, and we've not seen, like, the combination of both logics effectively has mostly taken care of the problem. But we still know that on some other platforms like ARM, for example, we don't get the needed information, and even some of our best guesses don't always work. So we've added now a config key to give you more control on that. You can straight up disable memory hotplug with limits memory hotplug 0. or you can set a specific limit. For example, limits memory hotplug, 2 gigs, 3 gigs, 4 gigs, which is then gonna start the VM with that specific amount of memory as the upper limit. And if you try to hotplug past that point, you're gonna get an error from QEMU. So that should take care of the problem for good, because now the default logic should work for 99% of cases, and when it's not, then you have some more flexibility. It also allows, if you know that a particular guest OS just does not handle memory hotplug correctly, you can turn it off so that there's no risk of accidentally changing the memory limit and then crashing the guest. Next, still in VM related features, we've got support for remembering the ejection state of a CD-ROM drive. So if you add an ISO as a disk, it shows up as a CD-ROM drive to the guest. And in the past, if you would eject it and reboot the VM, the drive would just reappear. Now it actually remembers that through a new attached property that we can see here, and it would effectively set attached false, which then means it will remember that on next restart, and if you want to change that, you need to clear that property so that the drive gets re-added. Then still related to disks and VMs, we've got support for setting the WWN field, so that's the worldwide name of the volume. It's a pretty, there's not many people are gonna care about that. It's maybe relevant if you're passing through a physical LUN from like a fiber channel SAN or something like that to a guest, and you want the guest to see the same ID as you're getting out of your storage. Or, and that's why I added it, it lets us do some amount of testing through VMs for things like multipathing. So effectively passing the same drive twice with like 2 disk entries, same backing file, same WWN, and then you can use the multipath daemon inside of the guest to load balance between both paths. Not terribly useful when both of the paths on the host side are backed by the same file. That it might get you more bandwidth, maybe, depending on what the guest does exactly with scheduler, IO scheduling and controllers. But it's quite useful to simulate what you get on a fiber channel SAN or similar storage arrays. Then another pretty feature that takes quite a while to explain, but has a pretty limited audience, which is you can now set the IPv6 address to a subnet instead of a specific IP address, and then a machine local address is derived automatically for you based on the system's MAC address. This is useful for clustered environments where you want to create a pretty lightweight network that spans multiple servers. You just want all of them to be kind of virtual L2 and have addressing working on it. When you want all of that to happen, you can't really do it on IPv4, but on IPv6 you can. The main issue we had was conflicting MAC addresses and conflicting IPv6 addresses. So fixing this feature effectively makes it so we can get a per machine IPv6 address without needing to manually configure any of that. It's tied to a machine specific MAC address, so there's no conflict at that level either. And now each machine can respond to can emit router advertisements. It doesn't matter which one the guest gets because they all advertise the same subnet anyways, so it's fine. And then each machine effectively acts as one potential default gateway, and it doesn't really matter which one the guest ends up taking, so it just all works. We're doing all of that as kind of preparation for some work we're doing in Incus OS, where we want to make it a lot easier to set up a cluster at home. And to do that, we can't really request people have a dedicated VLAN or that they're using Oven or that they're using any of those kind of mechanisms. This gives us something that basically works everywhere because it's just normal tunneling VXLAN on top of like IP multicast between the servers. It's fine. IPv6 makes it very easy for us to come up with a random subnet, so that's fine. And the addressing mechanism that we've added in this release makes it so that we avoid any kind of IP conflicts. All right. Next, we've now exposed the keepalive mode a bit more than we used to have it. So the CLI has had for quite a while now a built-in keepalive mode where you can effectively configure an amount of time in seconds. And after the first command you run, a background process is spawned that we can actually see down here called Incus remote proxy, which just sticks around for at most, or for that timeout effectively. If there's no activity, it will then exit. And any new command you run, instead of establishing its own connection to the backend server on its own, it goes through that proxy. That allows a bit more, like, to make things a bit more efficient. We don't need to redo all of the same requests to get basic server state and that kind of stuff. We can skip that. And we also get to use some amount of keepalive HTTP connections in some cases. So that can improve performance a fair bit, especially on high latency connections, and especially if complex authentication like OpenID Connect is at play. So now you can effectively just add --keepalive 30 or something like that when adding a remote, and it will use that, like set up that keepalive process for you. Next, still in the CLI, we now have a new output format for Markdown in lists, and that makes it pretty easy to then just copy paste a table into the forum or anywhere else that takes Markdown input. And we've also, still on the CLI, completed the migration to using server-side filtering for all of the collections. So this time around, we're looking at cluster list and storage list. They were the last two to be converted. They're there now. So it means whenever you do an incus something list and you pass a partial name or full name of something, instead of the client receiving all of the data and filtering it on the client side, it's now filtered server side instead. And last thing we're mentioning in the release announcement is the fact that we switched from directly calling the command line tools IP, TC, and the like, to instead making direct kernel calls through the netlink kernel API. This should not really be visible as far as change to, like, it's not really a new feature, it's an internal change, but we mention it because it has a reasonably high risk of regressions, because it effectively changes the way we set up all of our network interfaces and devices and IP addresses and routes and all of that across all of Incus. It's one of those changes we did immediately after the 6.14 release, so that we had an entire month to kind of test it and see how things go. That all worked fine. We found a number of regressions, we fixed them. As far as we know, everything is good. But if you see something weird that's network related after upgrading to 6.15, do let us know, because it might be related to this, and then we'll track it down and fix it. All right, and the last thing I wanted to cover before we actually go feature by feature is Incus OS. So as mentioned earlier, we've made some very good progress on it. It's now used behind the scenes whenever you run the online demo. So if I go to the online demo and just start a session here, we can see it's demo at Incus OS. And if we go look at the OS it's running, it is running Incus OS with yesterday's build, which then gives us Incus 6.15. So we moved effectively from an Ubuntu-based environment for the demo to using Incus OS instead. Works basically exactly the same. We haven't changed any of the instructions, the web UI and everything still works. But yeah, that was moved over to that, so that's gonna give us a lot more indirect users of Incus OS and a bit more experience on how that's going. We've also made available a tool to generate custom Incus OS images, and that goes into a few more details around requirements and the like. But there's a link to a forum post for that, with effectively a website with the tool here to generate your own Incus OS install or runtime media, and just get to download effectively a custom ISO or a custom USB drive image, and you can then put that on whichever media you want and start testing it. There's a detailed list of requirements at the top of the page, and if you've got any questions or anything, feel free to go on the forum and ask there. Also still kind of community related. On the forum, we are doing a bit more of an experiment using the built-in chat. So we effectively replaced the link to IRC to using the built-in chat within the forum instead. So if you want to just chat with us, maybe give that a try. We're gonna see if that works. That's one of the many options we're considering as far as how to have like a lower latency way of interacting with some of our users. All right, and now on to actually showing those different features. So let me just switch over to a terminal here. There we go. And let's go down the list. So the first one is OCI registries. So let me just remove the test remote I've got for that, which is OCI demo. Oh, it's already gone. Well, that's good. And then show how that stuff actually works. So I'm using Google Cloud. I've got a test image just in a private registry on Google Cloud for testing, but that would work for anything else that uses the Docker style credentials helpers. But what you normally do is effectively use the cloud command line. So in this case, Google Cloud login, I think, is the command that I want. Maybe not. Auth login, probably. So first thing first is you need to make sure that you are correctly logged in against the cloud. And I think I've got a creds file. Yeah. So you can do login. In this case, it's now overriding my existing login, but whatever. So from that point on, the cloud CLI tool is happy. It's fully logged in. Once you've got that, then you can go and actually add your remote. I'm going to copy paste it because the URL is quite long, but it looks something like this. So Incus remote add OCI demo, and then the URL of the registry itself. So in this case, it's this long thing. And then protocol is OCI. And finally, the new feature, credentials helper, and then the name of the helper, which in this case is Docker credential gcloud. You can actually look at like, there's that command on the system. If you've got a bunch of the different clouds installed, you can probably do docker-credential tab, and you're going to get a list of those. But yeah, we effectively do Docker credential gcloud. And once that's done, the rest of the interactions work exactly as would normally expect. So I can do image info, OCI demo, Alpine latest. And yeah, there you go, it's getting the image. So that's how that works. It basically works the same way as in Docker. So any private registry you might be interacting with should just work now. Next, we've got webhooks. Okay, I think the system might still be configured for it. So let me just unset some stuff. So logging, demo, target, address, and type. So we're just gonna clear that stuff. Then I'm gonna start a basic web server. This is just a basic, yeah, well, apparently I still have some stuff running. Okay, just restart Incus real quick. So it's just a basic web server in Python that happens to also log every single request being made. That's quite useful. In this case, you just see what you get, but normally you would be using, you know, something like some other platform on your side, like your own application, to effectively receive those webhooks. Okay, so configuring that stuff, you effectively have a minimum of 2 keys to set. So one is the address itself, which I can set to my server. I think it's on, is it 8,000? No, it's 8080, okay. So I can do 8,000 my hook, and then we need to actually give it the type, which is a webhook. And just by doing that, you can see we immediately got some stuff. The first one is a logging entry that shows just a connection to an event listener. And the second one is a lifecycle update that actually covers our change of config. So the config updated notification is already received there. You can see it was pushed to my hook. The content type is application JSON. We've got the right size, it supports compression. Like, it's pretty normal HTTP request effectively. So that can be pretty useful if you want to do your own handling of specific Incus events on your side, whether it's logging, whether it's a lifecycle. You can restrict things to also a single project. Like there's quite a bit of flexibility, and that might be a pretty good way to know when something changes or is going on your Incus server or cluster. Okay, next up we've got the memory hotplug. So let me just check what I've got as far as VMs here. Okay, I've got D13, so let's stop that one and see. I don't actually know what its config looks like right now. Okay, it does have the memory hotplug limit already, so let's just clear some of that stuff. We're just gonna go then set D13 limits memory and memory hotplug. So we're just gonna clear those two. And in that environment, we'd have the normal VM, so it would get online with, in my case, a limit of 1 terabyte of RAM. Obviously, my machine doesn't have that much RAM, so not exactly recommended to try and use that, but you know, you could. So we see 1 gig right now, and I can obviously go D13 limits memory 8 gigs, and it just grew that extra memory. So that's what you can do out of the box. Now, if I stop that VM and I go limits memory hotplug 0, and for good measure, I go and unset limits memory. So we go back to 1 gig, then start that. Give it a few seconds to actually boot up, but it doesn't really matter because the test would be to just do the same thing. Bump it to 8 gigs, and this time it's telling us memory hotplug feature is disabled. So you just can't do it when it's set to 0. Now, if I stop it again and hotplug, we bump it to, say, 4 gigs. Now we're gonna get effectively talking with QEMU, so the errors will probably get a bit worse. But if I do 8 gigs again, not enough space, so effectively it's complaining that it can't fit that memory. If we go and do something smaller than that, so if we do 3 gigs, then it goes and does it. So that's effectively the limit. It lets us configure the maximum memory limit on the QEMU side, and then how we get to that point, like how much has been hotplugged, how much was already there, depends VM to VM. Okay, I can stop that one. Next, we've got the persistent CD-ROM. So I think I'll also use that one in the demo. So let me check. Yeah, it does have, so we can actually see it. It has a drive currently marked as attached false. So let's just start it back up and see what's going on. As it stands, because it's detached, it's not gonna, it shouldn't show us the drive. So if we go in there and we try to mount the CD-ROM, there's nothing in there. Now, I've not actually tried to do it live, but that should still work. So let's try to just clear the property. And yeah, now it's mounted read-only, so we can see it's there. If we go look at the config as it stands, the drive is just attached, so if we reboot, it would come back up. Now, if I eject it and just give QEMU a tiny bit to update, there we go, attached false. So now it remembers that it's been ejected, and that means that right now, because it is ejected, I can't mount it. And if I reboot the VM, again, I won't be able to mount it unless that property gets cleared. So that's just persistency of a CD-ROM tray state, effectively. Okay, next is the WWN. So let me check if I can show the multipath stuff as a demo for that one. Do I have a shared volume? I do not. Let's create one. So do default shared size 10 gigs block, and we want security shared true. Okay. Let's stop the VM and then attach that volume twice. So we can do D13, D1, disk, oops, device and disk. The pool is default, the source volume is called shared, and WWN. So those need to be written effectively in hexadecimal and be an integer. Trying to remember the size, like 64-bit integer or something. But like it's a standard format for WWN, so we can just do that. That's D1, and then we can do D2. And for good measure, we can add it 4 times just for fun. And then show you what that looks like in the guest. So if we start that, we're effectively going to get a guest where it's root disk instead of normal root disk, but then it's going to have an additional 4 disks, each showing the same 10 gigs, same vendor, same stuff. And because we've got the WWN, we are actually able to do multipath in the guest. So if we check here, we can see same disk 4 times 10 gigs. Now if we go look at the by ID view, what UDEV did is that it just picked one. So it noticed the ID was the same for both, for all 4 of them, and you just have one symlink. So if you were to use the by ID WWN, it would work fine right now. The problem with this is that it would only use one of the 4 paths. So if you were actually providing different paths to different, like their own controllers and separate throughput, you would only get a quarter of it. That's where tools like multipath tools and the multipath daemon come into play. So you'd install that, and once it's running, it will start keeping track of drives with the same WWN. So for now, it's still looking the same, but we can do multipath-a and then provide, I think it just wants WWN. So if we just do that, okay, it says added, and then we need to tell it to actually apply the config. No, it didn't. Yeah, it hasn't seen it. Okay, so does it want it without the 0x? I never remember what syntax, what tool needs for that. Reload. No. Or it might want the actual device. Hold on, that might be it. It might need one of the devices to figure out what it is. So let's try that. There we go. Okay, so it wants one of the devices. So I just gave it SDB, and from that it figured out the WWID, which is, yeah, oops, this part here. This one is weirdly formatted actually. So anyway, it derived the actual WID and then started tracking. So now we can see we've got 4 paths. And if we look at the by IDs, now they've been rewritten to use a device mapper device, which effectively provides the direction and can do all kind of load balancing and selecting the right path and all that kind of stuff for you. So that's, I was doing multipath work. I needed some way to test it in VMs. That's why I added the WWN feature. But the other use case I mentioned earlier is if you're doing pass-through, so if on your host system you do have a drive with a WWN and you're passing that into the guest, you might as well set the property so that the guest sees the exact same thing as it would on at the hardware level. All right, next up we've got the dynamic IPv6. So for that I need a cluster, which thankfully I have here. My usual demo cluster of 4 servers, so nothing that, like, if you might have seen it before. As with all networks and storage on clusters, we need to first define the machine specific information, and then we can create, we can set the global information. In the case of machine specific info, in this case, the name of the interface for the tunnel is machine specific. So that's what we need to specify. All 4 of them, in my case, are the same. So it's just the same command 4 times, changing the server name. And then we get to the interesting piece, which is creating the network itself. And the command for that is this thing. So as mentioned, IPv4 is not going to work well if you try to enable that, because you're going to have 4 different DHCP servers with their own view of things. You shouldn't try to do that. You should just do static IPv4 if you need IPv4, or just no IPv4. So in this case, I'm going to turn off IPv4 completely. IPv6, I came up with a subnet, but as you can see here, there's no address part. It's just colon, colon, and so it's just zeros at the end. There's no machine, there's no address bit set. IPv6 NAT should actually be true. I'm not sure why the example was false, but anyways. So we turn on NAT on IPv6. And then for the tunnel we're defining, the protocol is VXLAN. That's a global setting, so that's why it goes there. When we do that, we then get a new network. And if we look at this particular system I'm on and look at mesh BR0, we can see our network bit here, and then it generated a address 1 here, which is based off the MAC address that's generated for the interface. We can see it's contains the same digits, and that's stable. So if the machine restarts or Incus restarts, we're gonna get the same thing. Once you've got that in place, now we can start actually launching some containers. So we're gonna do C1, C2, I think C3, because I just need them to hit different machines for the demo to be actually useful, to just show it works. And here we go. Now we can see C1, C2, C3, it's running across 2 different servers, 0401. So if we go on the first one and we try to ping the second one, that's gonna go through our VXLAN. Other than that, like we see the lowered MTU because of the tunnel, but everything else is basically normal. One thing that will look weird is the default gateway. Each of the server advertises its own, the client receives all of them, and effectively it's kind of up to the container what it does. Some cases they will just pick one, like the oldest as the main one. In some cases it actually load balances based on connections. It doesn't really matter. Connectivity should generally be fine anyways because they all NAT. So long as it just takes the same path within the same connection, it all works fine. And that's a very, very basic tunnel virtual network we can use now on top of clusters as a way to then run some of our own services on top of it and have that be accessible from all machines. All right, next we have some CLI work. So going back here to my CLI, I can show the, actually can redo my demo from the post, just show what it looks like when accessing, actually it was cloud, this one from the post, what that looks like when accessing a remote Incus server, in this case using OIDC. So if I run this, it's actually starting a prompt, like it's gonna start a prompt for authentication in a few seconds. We can see the config key here for the keepalive, and yeah, I'm on separate screen. I'm not getting the login screen here, so I'm just gonna log in. Here we go. Okay, and from that point on, if I run any action against it, let's select project demo. Okay, if I go look, now I'm gonna have that Incus proxy process here that's running for a few seconds. There's a timeout of 30 seconds, so 30 seconds since the last time I ran a command, that process is gonna go away. But until then, it allows for faster connection to the target cluster because it caches some of the common queries that the client does every time. And it tries to do keepalive as much as it can with HTTP as well. It's still there, but should go away in a few seconds. Okay, next up is Markdown. So is it gone yet? Yeah, it is. There we go. That one is basically as simple as it gets. So you just do list format Markdown, and there you go. You've got a Markdown output. It also means that if you use, we've got a configuration key within the config file for the default formatting for tables. You can now use Markdown in there too, and you just get that kind of table from that point on. It's pretty useful if you need to copy paste examples into, like a document of some kind or on the forum or something like that. And then we've got server-side filtering. So as mentioned, I'm just going to show it with storage list. If I've got more than one pool, I don't. Let me check on the cluster. I think that one will be more interesting. Yeah, so we've got 4 servers. If I look for 01, that does the filtering, and we get the same thing for pools. If I do list and I type the beginning of local, then it will do the filtering for that too. We've already had that for every single other command in the CLI. It's just kind of wrapping things up with the last 2. And that's it for Incus 6.15. That's all the new features. Also, as mentioned, like we're doing more and more with Incus OS. We're using it for the demo now. We've got some more folks playing with it. And we're adding some features to Incus that can tie in and will make that a more complete experience. Anyway, I hope this was useful to you. If you've got any questions, feel free to leave them down below in the comment section, or you can go on the community forum, which, as mentioned, also has a built-in chat. So if you prefer to use that, you can use that feature. And I'll see you in the next one. Bye.